All right. Let's see what we can do with this bell work. Number 1 says to solve the equation. What do you notice about this equation? What type of equation is it? What type of equation is it? What do you notice about it? Hmm?
Number 1.
Yeah, number 1.
It can be squared.
What can be squared?
49.
49. We square the 49?
Or 7.
We could do 7 squared. Did you have an idea, Julia?
Yeah.
Same thing?
Yeah, 7.
Yes. So this is an exponential equation. How do I know by looking at it that it's an exponential equation? It has an exponent that's a variable, yes. In this case, an exponent of x. Anytime we have something where there's an exponent that has a variable in it, it can be more than one that has a variable in the exponent, but at least one of the pieces of my equation has an exponent that's a variable. And I love what you guys said, that we can take this 49 and we can rewrite this as 7 squared. What do I do with that exponent of x? Yep, just bring it down. This comes straight down. Over here on this side, I have 7, but that doesn't have an exponent on it. If I don't see an exponent, what's the invisible exponent? 1. Just like I can take any whole number and turn it into a fraction by putting it over 1, I can look at any base and give it an exponent of 1. Why did I want to do that? What's the importance of having these two match? Yes, if your bases are the same, then your exponents, these pieces right here, are going to be equal. So 1 is equal to 2x. How would I solve that now? How do I get x alone? Divide both sides by 2. So x is 1/2. Beautiful. Number 2. Similar kind of setup, except I got this fraction. What can I do with either the left or the right? Give me one idea that I can start with. 16 is 4 squared. So this is the exact same thing as 4 squared. Do I need to bring down any exponents with that? Should I put parentheses around it and put something out here? Why not? Yeah, the 16 didn't have an exponent on it, so I don't have another exponent that I need to bring down with it. Equals, does this base that we just changed this one into and this base match? This is a fraction. 4 to the negative 1. Anytime you see a fraction, we know our exponent is going to be negative. 1/4 is equal to 4 to the negative 1 power. So I'm going to rewrite this as 4 to the power of negative 1. Do I need parentheses around this one with something out to the side? Yes. What needs to go outside those parentheses? The x right here. And why am I so happy at this point that these two bases match? Tell me one more time. Yes. Yes, if the bases match, then my exponents have to be equal to each other. How many exponents do I have on the left-hand side? 2. I've got the one inside the parentheses and the one outside the parentheses. What do I do with those two things? If I have 2 exponents, what do I have to do with them? distribute, I have to multiply them. So I have a negative 1 that's getting multiplied to the x, and that's going to be equal to what? Negative 1x, but what do I set it equal to in my equation? 2, this exponent over here. So I have negative 1x equals 2. What do I need to do now to get the x all by itself? Divide by negative 1. That makes my negative 1 over here cancel. What is 2 divided by negative 1? Negative 2. Beautiful. All right, let's look down at the 3 questions on the bottom. Not A, B, C, 3, 4, 5. Thank you. We've got a reminder about our properties of exponents. I want to look at this reminder real quick before we come down here and look at these. And then we're going to solve problems, or simplify problems rather, just like these for our lesson today. All right? What do you notice about these 2 bases? They're the same. When my bases are the same, and what's in between them? Multiplication is between them. What do we do with the exponents? We add them. We've looked at this one before. When I have an exponent inside the parentheses and an exponent outside the parentheses, what do I do with those pieces? Multiply them. What about with a fraction? First of all, tell me what you notice about the bases on this one that's set up as a fraction. Same bases. When the bases are the same, top and bottom, and they both have exponents, sometimes they cancel. We can subtract them, yeah. Sometimes there's more on top than there are on the bottom. If it's the same number top and bottom, then all of them will cancel out. What about if there's more on the bottom? It's going to stay a fraction, or I'm going to have a negative exponent. Yes. All right. So let's look at this. On number 3, what's my base? X. Do my bases match? Yes. These are the same. What's in between them? Multiplication. So what do I do with my exponents when that's the case? I'm going to add them. We multiply them when I have one base and it has an exponent inside and an exponent outside. That's when we multiply those exponents. But here, when I have 2 bases that are the same and they both have exponents, multiplication in between, we add those exponents. I'll give you an example of why that is. Okay? Let's finish this problem, and then I'll show you an example. So I would have x to the power of 5 plus negative 3. Now I need to simplify this. What is 5 plus negative 3? Positive 2. So this would be x squared. All right, so I'm going to do an example off to the side of why this is true. Let's look at x to the 3rd times x squared. I'm not going to deal with something with negative exponents right here in my example. What does it mean for something to be cubed? Multiplied by itself for cubed 3 times, right? So x cubed means x times x times x. I'm going to bring down the multiplication that's in between. Notice everything is being multiplied so far. What does x squared mean? X times itself. So this means x times x. How many x's do I have that are all being multiplied together? 5 of them. That's why we add those exponents. Exponents means how many times I'm multiplying something by itself. And if I multiply in between them, I'm just tacking on more that are being multiplied together. Does that make sense? Okay. The middle one, I have to be careful here. What's in there with that x to the fourth? Coefficient of 2. So what it means to be cubed means I multiply it by itself how many times? 3 times. Right now this is being multiplied, so I have 2 times 2 times 2. That's coming from this. So that's 2 cubed. And then x to the fourth times x to the fourth times x to the fourth. So that would be x to the fourth to the third power. So I have to simplify these separately. What is 2 cubed? 8. And what do I do with x to the fourth to the third? Multiply those exponents together. So this would be x to what power? X to the 12th power. Notice that that 3 on the outside of the parentheses didn't just affect my x to the fourth. It also affected that 2. It meant that I had to do 2 times 2 times 2. So far, so good? All right. Let's look at the last one. So there's 2 things I notice going on here. I have these x's that are being divided, but what else is being divided? The 8 and the 2. So I'm going to treat these separately. 8 divided by 2 gives me what? 4. And what would I do with these x's? They same base, and they both have exponents on them. So what do I do with those exponents? Subtract them. That would be 7 minus 4. Well, what is 7 minus 4? So 4x to the third. This piece I can write out and explain why. X to the 7th would be 1, 2, 3, 4, 5, 6, 7. X to the 4th would be x times x times x times x. Anything that's the same top and bottom will cancel out. And you can see I'm left with 3 x's that are still being multiplied together. That's why we're doing that subtracting there. Make sense? Notice I dealt with those coefficients differently than I dealt with the x's. I have to divide and simplify those numbers. And then I also have to deal with the bases and their exponents, my variables. All right. Keep your bell workout because it's got our exponent rules on it. And grab that stapled piece of paper that you should have picked up at the front. This is our notes from now until the test. Does anybody remember when our test is? I've thrown it up on the board a couple times. 16th. It's next Thursday.
I thought we got e-learning next Thursday.
No, we got e-learning day tomorrow.
Oh.
E-learning day is tomorrow. Before the bell rings, I'll show you what you need to do for me for tomorrow. There is not going to be a live Zoom. You're going to have 2 things that you need to complete for me.
Are we going to Zooms and other people?
Not tomorrow. In March, we'll have another e-learning day, and that one will have Zooms for all your teachers. They'll be short, though. I think they're like 15 minutes long. So it's not going to be like when we were asynchronous or synchronous a couple years ago and you went to your Zooms. It also doesn't start until like 8 in the morning, so you guys get to sleep in on that day too. But tomorrow, you're not coming to school. No teachers are doing Zooms with students tomorrow.
Just work.
Just work. Yep. Some of your classes, you might have a video that you need to watch. Some classes, you might need to take notes or read something. In here, there's going to be 2 activities that you need to complete for me.
Just do that 223.
Mine is set to close at like midnight, I think. So you'll have like the whole day to work on it. Right. Everybody have this page out? All right. So we're going to learn about a new base today. There is a number called E. Have you guys ever heard of pi before?
Yeah.
What is pi?
3.14.
If you abbreviate, yeah. Does it actually stop at 1/4?
3. I don't even know the rest of the numbers.
I used to have a poster with a whole bunch of numbers up on it. It's like 3.14159. That's as far as I can get. And that's only because a couple years ago we hit like Pi Day because of the year.
Where I'll be.
So 3.14, that would be March 14th.
Oh.
And then at 1:59 p.m., we like celebrated like it's Super Pi Day. So that's why that one's stuck in my head. But it goes on and on and on. It's this number that doesn't ever stop, and it never has a pattern that repeats itself in there. E is a similar kind of number. I don't know why they picked something that's just a normal alphabet letter to stand for this. Well, I kind of do. The person that found this and talked about it and wrote about it, his name was Euler. But he wasn't an American, so it's actually spelled with an E in the country that he comes from. This is called Euler's number. Yeah, it looks like Euler, but where he was from, it's pronounced differently. It was pronounced Euler. So I'm not going to get picky about the pronunciation, and I don't ever expect you guys to remember that later. But what I do expect you to remember is that E is a number. It's not just a letter, and it's not a variable. It's a number like pi is. There's all these different ways that we can talk about it. When they say E is irrational, that means it never stops and never repeats, like pi. That's what it means for something to be irrational. Here is the approximate value for E. Just like pi is like 3.14159 something, 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 something. E is about 2.71828 something, 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 something. That's about as deep into E as we're going to get for today. I want you to know that it's a number. We can use it as a base. This is actually a really powerful thing. It sometimes gets called the natural number. Because we find that when we use this number, this irrational number, as a base in exponential functions, it helps to really closely model what we see about how populations grow. Like when we see bacteria spread really far or viruses spread really far, this as the base with an exponent on it helps describe how we see it growing better than any other base that we have. So it happens a lot in the natural world. That's why it gets called the natural number. All right. I just want to practice with some properties of exponents using E as our base instead of a variable. You guys okay with that? Exactly like we did on the bell work, though. So on this first example, do my bases match? Yes, they're both this number E. What's going on between them? They're being multiplied. So what do I do with these two exponents? Add them. So e to the power of 7 plus -2. which would be e to what power? Fifth power, yes. Head up for me, Jefferson. Stay with me.
Do we have to put plus and negative two, or do we just put negative?
Can you, like, could you do 5 minus 2?
Like 7 plus negative 2. Can we just put 7 minus 2?
Mhm. Yeah. I'm glad you pointed that out. Subtracting a negative is, adding a negative is exactly the same as subtracting. I'm actually really glad that you pointed that out. This is the second time that we've seen a negative show up as my exponent when we're multiplying two of the same bases together. What do negative exponents do to their bases?
Make it a fraction.
Makes it a fraction, so it would be 1 over e to the second. Middle one here. We have a 4 on the outside of the parentheses. That 4 will affect what? Everything. It's going to affect this negative 3. So I'm going to have negative 3 times negative 3 times negative 3 times negative 3, which is the same thing as negative 3 to the 4th power. I'm going to pop him inside parentheses. And then it's also going to affect this guy. E to the 2x times itself 4 times. What's negative 3 times negative 3? 9. Positive or negative 9?
Positive.
Positive. And this negative 3 times negative 3?
Positive 9.
Positive 9. So I'm going to multiply those together and get what? 81. Grab your calculators for me real quick. I want you to put this in the calculator without the parentheses around it. Put this into your calculator, but without the parentheses. So just type negative 3 and then the exponent key and a 4. But we said it was positive 81. Who's right?
The calculator.
Nope.
I mean,
We are. Why do you think your calculator's wrong on that? What did we not put in? The parentheses. So what your calculators are, you have to put the parentheses around there if you're going to take a negative number to a power. Have to, have to, have to. Otherwise, your calculator's going to screw up. If you do negative 3 and then you put the exponent on it, your calculator doesn't understand math. Not really. It's just been programmed kind of like a computer. And so it's going to follow the order of operations precisely. Order of operations is parentheses first. You didn't put those in. And then exponents next. So it's going to go, what has an exponent? Oh, 3 has an exponent. So it's going to do 3 to the power of 4. And then it's going to multiply the whole thing by that negative at the front. That's not what we wanted it to do. We wanted it to take all of this whole negative number, and multiply it by itself 4 times. So anytime you put a negative in the calculator and you're going to take it to a power, you have to have those parentheses around it. Otherwise, you're going to get the wrong answer. What would I do with this part over here, the e to the 2x times, or to the power of 4? What do I do with these? Multiply them. So what is 2x times 4? 8x. So this is going to be e to the 8x. Last one here on this example. Very similar to our bell work. What are the pieces that I need to pay attention to? Like, how should I approach this problem? How many things are going on? It's a fraction. does the top of the fraction contain? Has an exponent. What is the thing that has an exponent on it? E. Is there an E with an exponent on the bottom? All right. So I'm going to look at those as one piece, and I'm going to use my properties of exponents there. What else is also part of this fraction? 42 and 14. I'm going to have to divide those separately. I have to simplify those on their own. 42 and 14. Is that going to go in evenly? I don't know. Find out. Try your calculators. Do 42 divided by 14 on your calculators. Three. What should you do if it doesn't come out evenly?
Make it an exponent?
Make those front numbers an exponent? No. We'd have to leave it as a fraction, right? If it doesn't give us a whole number when we divide it. Simplify it, we would reduce it. So if it doesn't go in evenly, then we'll reduce that fraction if we can. So like if I had, let me think of a good example. 12 over 14. If that was 12 over 14, that would not have gone in evenly, right? But could I reduce 12 over 14? Is there a number that goes into both of those? Yeah. So 2 goes into both of those. I could reduce it down that way. All right, so here's what I got from the numbers. What do I do with these e's to the power? Yep, we're going to subtract this. So this is e to the power of what? 2, because we do 7 minus 5. So I get 3e squared. We are almost done. I want you guys to try the problems at the bottom. There's 3 problems at the bottom in that check section. We're going to check to see how well you've understood this. Once you're done with the check, we are done for today. Try that check down at the bottom.
How do you sort of work when you do it? Do you have to break this down?
Not necessarily.
On the test, we have to sort of work for these problems?
For the first one, for one like that first one in the check, or like part A up here, I wouldn't have to see any work. Like I could believe that you could do that in your head. For one like the middle one, I would want to see a little bit of work because that one's a little bit more complicated. Absolutely. There you are, sir. You're welcome. attention yet, I'll be there.
Oh, you think they come today?
And then there's gonna be another piece to the problem. That E, right? Here's those powers. What do you represent on this? What's it have to do with
They
the
would
two
not do
X's?
I used to work there too.
Yeah, and what did I do with it now?
2016, 17.
Look at my final answer, I'm gonna E to the 8x. Two x and 4. What would you want to do? 2x and 4 to 8x. Yes. So what are you gonna do? Yes.
Yeah, for y'all today. That's the only reason why you doing that.
This is 36, right? There's 36. And in between, and kind of.
You call me Mr. Dick. You know, say
All right, let's look at these. I'm seeing a lot of really good things on your page. However, I am seeing one thing that I thought might trip us up, and I'm seeing it a lot. So we're definitely going to talk about it. On the first one here, so I'm looking at this guy. What are all the exponents that you see? Yeah, there's a 4 here. There's a 3 here. And they didn't write the other exponent, but this is an exponent of 1. I have to include that when I'm adding these together. So this would be e to the 4 plus 3 plus 1 more. So this is e to what power? E to the 8th power. As I was walking around, I was seeing a lot of e to the 7th powers, and I totally understand why we did that, but you have to include that last e on the end because he's being multiplied 1 time. Yes?
Are you gonna show on this test, like the 1?
No. You have to know. Like, if you want to write it down, if you always want to add it in for your own benefit, yes. But anytime you see a base and there's no exponent on it, it is understood to be a 1. So you should probably draw that in there. All right, middle one. What's going on here? Everything inside the parentheses is being taken to the 4th power. So I have 6 times itself 4 times, which is the same as what? 6 to the 4th power. And you evaluated that to get what?
1296.
1296. All right, and then what else is happening in this problem that I got to take care of?
E to the 2nd power x.
Yes. Here, there's no x. It's e to the 2nd power, and then that's all being taken to the 4th power. So what do we do here? Multiply those together. So I would have e to what power? E to the 8th power. So 1296 e to the 8th power. Last but not least, what are the pieces I have to pay attention to and kind of separate out and deal with differently? Yes, the 60 and the 12 get dealt with by themselves. What is 60 divided by 12? 5. And then what else do I have to do?
Minus the
Yeah, subtract those 2. So I have 6 minus 2, which is e to the power of 4. Awesome. We are stopping there for today. Please make sure you hang on to this notes packet. We're going to do the back side of this page on Friday, and then we'll do the 3rd page on Monday. There is a homework over this that is due Friday. 7-2 homework, though, by the way, is due today. I haven't put that in the grade book yet, but it's due today. 7-3 homework is a McGraw-Hill homework. It's due on Friday. It's pretty much just using what we did today. What you guys need to do for me tomorrow, go to modules, and I will make sure that this is open today, so if you wanted to start on it ahead of time, you could start on it tonight. You want to scroll until you see tomorrow's date, so Thursday. These are the two things that you need to complete for me. The take-home quiz, which is that other piece of paper that you picked up. This guy right here. Open notes, open homework. It's just one side. You need to complete this. If you want to, you can submit it on Canvas, snap a picture of it with your phone and upload that picture, or you can bring it back on Friday and turn it in. Either one of those is fine. I'll take it either way. And then there is this activity right here that reviews what we did in 7.1 and what we've done so far in 7.2. None of the stuff that we haven't covered yet. So far, so good? All right. I did put this up here because you can get started on it. It's not due until Friday. These are the two things that you need to do for your e-learning day. This guy right here and that thing with the rocket ship. Sound good? All right. I will make sure that this is open tonight in case you want to get in and do that. You have an unlimited number of attempts at this, so if you don't score great the first time, you can do it again. It should show you which ones you got right and which ones you got wrong. If it doesn't, send me a message. I'll be in conferences all day, but if you send me a message, I'll try to get in and fix it and see what's going on. Sound like a plan? Does everybody know what's happening for the remainder of this week? Yes. So I'll see you again on Friday. We'll keep talking about 7.3. We'll finish up on Monday. That'll leave us Tuesday and Wednesday to review for your test. So on Monday, I'll give you the review for the test. Tuesday, Wednesday, we'll review. Thursday, we'll take your test.